Recorded by Mike Ferry 252. In all ways but one, our scrutiny of the planet is confined to such view as we might get of it from the car of a balloon poised above it in space, from which disadvantage point we should see the surface only as a map spread out below us, a matter of but two dimensions. The exception consists in the observation of what are called projections, irregularities visible when the disk is gibbous upon that edge of the planet where the light fades out. Striking phenomena in themselves, they are of particular value for what may be deduced from them, for by them we are afforded our only opportunity of gaining knowledge of the surface other than in plan, and thus of determining between peak, plateau, or plain, that to a bird's eye view alike lie flattened out to one dead level. It might at first be thought that our best chance of noting any elevations or depressions of the Martian surface lay in catching that surface in profile by scanning the bright edge of it, which stands sharp cut against the sky and is called the limb. For this is practically what we do on Earth when we mark a mountain against the horizon and measure its height by triangulation. Unfortunately, the method fails in the case of Mars because of the great distance we are away. Unless the planet were distinctly more generously equipped than the Earth in the matter of mountains, nothing could be hoped from so forthright an envisaging. So relatively insignificant to the size of its globe is the relief of the Earth's surface that an orange skin seems grossly rough by comparison. The same proves true for Mars. With the greatest magnification we can produce, the Martian limb still appears perfectly smooth. Luckily, while direct vision is thus impossible, oblique illumination enables us to get an insight into the character of the surface we had otherwise been denied. When mountains or valleys chance to lie upon the boundary of light and darkness, the rim of the disk, known as the terminator in contradistinction to the limb where the surface itself comes to an end, they make their presence evident through an indirect species of magnification. The elongate effect of oblique lighting, with a practical instance of it, everyone is familiar who has walked by night along a road, imperfectly starred at intervals by electric lights, startled between posts by what seemed deep holes and high furrows. He has involuntarily imitated a spavined horse, for fear of stubbing his toes, only to encounter when his foot fell a surface on contact surprisingly smooth. The slant illumination by lengthening the shadows had painfully deceived him into exaggerated inference of irregularity. What proves disturbing to a wayfarer misguided by arc lights is made to do the eye's service when it comes to planetary interpretation. On the boundary of light and shade, those parts of the surface where it is sunrise or sunset upon the planet, the sun rays fall so athwartwise as to throw enormous shadows from quite small elevations to an eye so placed as to view the surface with anything approaching perpendicularity. A mountain mass there will thus proclaim itself by protracted profile upon the plane in hundredfold magnification. Similarly, a peak there will advertise its height by catching the coming or holding the lingering light at many times the distance of its own elevation from the night side of the planet. Here, if anywhere, then could mountains be expected to disclose themselves, and here, when existent, they have, as a matter of fact, been found. Our own moon offers us the first and easiest example of such vicariously visible rhythm. When the moon is near the quarter, and for 3 or 4 days on either side of that, a keen eye can usually detect one or more knobs, like warts projecting from its terminator, easily distinguished from the limb, both by reason of being less bright and of being bounded by a semi-ellipse instead of a semicircle. If a telescope or even an opera glass be substituted for the eye, it is possible to see what causes them. The knob resolves itself into the illuminated rim of a crater separated from the main body of the visible moon by the seemingly black void of space. The peak has caught the sunlight, while its foot in the country between it and the illuminated surface still lies shrouded in shadow. For measurement of the distance, the sun-tipped peak seems to stand aloof from the line where the plane itself is touched by the light. The height of it above that plane may be calculated. In this way have been found the heights of the mountains of the moon. Incidentally, rain outstrips broad. For pinnacles no lunarian could scale, both for their precipitous inaccessibility and their loftiness. Man is measured without so much as setting foot upon their globe. At each lunar sunrise, and again at lunar sunset, these old crater walls show their crescent coronets tipped the reverse way, and peaks higher than the Himalayas make gigantic gnomons of themselves with hands outstretched to grasp the plains. In this manner, a lunar peak of 15,000 feet shows its presence to the unaided eye. With so much for starting point, we can calculate how low an elevation could similarly be made out on Mars under a like phase illumination. Now, in spheres of different diameters, the distance out from the terminator for a given height is as the square root of the diameter. Mars has about twice the size of the Moon. In consequence, if we saw the planet at the same distance off as the Moon, the height of a peak upon it sufficient to cast an equal shadow or be seen at an equal separation from the terminator need be but 2/3 as high. To see it, thus equidistant, a power of 250 or 300 is necessary, dependent upon the opposition. Twice this power may at times be used, and by the same reason, this would reduce the height sufficient to show by 4 or 2 something like 2,500 feet. This, then, will be the theoretic limit of the visible, a limit needing to be somewhat increased because of the imperfection of our air. Having found thus what should be visible on Mars, we turn now to see what it is. At once we find ourselves confronted with the very unlunar state of things. Common upon the face of the Moon, excrescence of the terminator are rare on Mars. The first ever seen was detected by a visitor at the Lick Observatory in 1888. Since then, they have been repeatedly noticed both at the Lick and elsewhere. But although observers are now on the watch for them, they are not very frequently chronicled, not because of everyday occurrence. Much depends upon the opposition. Some approaches of the planet proving more prolific of them than others. How rare they are, however, may be gathered from the fact that the last 3 oppositions have disclosed but one apiece. An account of the Great Projection of May 25, 1903 will give an idea of the extent and interest of the phenomenon, and will serve to show to what cause we must attribute all such that have been visible on Mars. For the behavior of this one was typical of the class. About 8:30 in the evening of May 26, 1903, Mr. V.M. Slipher, astronomer at Flagstaff, shortly after taking over the telescope, then directed upon Mars, suddenly noticed a large projection about halfway up the terminator of the planet. He at once sent word of the fact, and the observatory staff turned out to see it, for a projection has for workers on Mars the like interest that a new comet possesses for astronomers generally. In this case, the phenomenon was specially potent in that it was the first to be detected that year. Its singularity was amply seconded by its size, for it was very large. Its extent, both in length and height, being excessive. When I first saw it, the projection consisted of an oval patch of light, a little to the north of the center of the phase ellipse, lying parallel to the terminator, but parted from it by darkness to the extent of half the projection's own width. It made, thus not simply an excrescence, but a detached isolate of light. It was easily seen by all those present and was carefully studied from that time on by Mr. Slipher and me. Both of us made drawings alternately at intervals, as well as micrometer measures of its position. Next to its great size, the most striking feature about it was its color. This, instead of being white or whitish, was ochre-orange, a hue closely simulated to the tint of the subjacent parts of the disk, which was the region known as cracy. This distinctive complexion was kept throughout the period of its apparition. At the same time, Baltia, a region to the north of it, and synchronously visible close upon the terminator, showed whitish. The seeing was good enough to disclose the Phison on Euphrates Dub, the power, a magnification of 310, and the aperture, the full aperture of the 24-inch objective. From the time it was first seen, the detached patch of light crept in toward the disk, the illuminated body of the planet. 4 minutes after I noted it, the dark space separating it from the nearest point of the terminator had sensibly lessened. So it continued with some fluctuations intrinsic to the atmospheric difficulties of observations generally and to the smallness of the object itself, to become gradually less and less salient. It lasted for about 40 minutes from the moment it had first appeared to Mr. Slipher, and then passed from sight to leave the edge of the planet, smooth and commonplace again. The measures made on it show that it lay, when first seen in longitude 39.7 degrees, latitude 18.5 degrees north, and that its highest point stood 17 miles above the surface of the planet. It was 300 miles long. These are my own figures, from which Mr. Slipher's do not substantially differ. The return of the part of the planet where it had been seen was eagerly awaited the night after by both observers to see if it would bring the projection with it. For only once a day is the same region of Mars similarly presented. But in order not to miss the projection, should it be ahead of time, observations were begun before it was due. Shortly after they were started, there appeared higher up the terminator, and therefore farther north than had been the case the night before, a small projection. It was with difficulty made out and its position measured. Without careful watching, it must have been missed altogether. As it was, it differed in every respect from that of the preceding day. It was not nearly so high, not nearly so large, and lay in a different place on the planet, being now in longitude 31.7 degrees, latitude 25.5 degrees. Either the two, therefore, were totally different things, or the projection had moved, in the elapsed interval of time over 7 degrees of latitude and 8 degrees of longitude, a distance of 390 miles in 24 hours, where the previous projection had been nothing shown. On the following night, May 28th, no trace of anything unusual could be seen anywhere. We are now concerned to inquire to what this series of appearances could have been due. The first observers of projections on Mars had unhesitatingly attributed them to the same cause that produces projections on the moon, to wit mountains. Such they were held to be in France and at the Lick. This view, however, was in 1892 disputed by W. H. Pickering, who considered them to be not mountains but cloud. And this view was strongly supported by A. E. Douglas, and a discussion of a large number of them observed in 1894 at Flagstaff. The mountain theory of their generation was finally shown to be untenable, and their ascription to cloud conclusive proved to be the correct solution by the observations of a remarkable one made in December 1900 and the careful study to which by the writer they were subjected. We shall now explain how this was done, and we will begin by pointing out that the fact that only a single specimen of the phenomenon was visible at each of the three oppositions of 1900, 1903, and 1905 was itself conclusive, rightly viewed, of their non-mountainous character. This conclusion follows at once from the isolatedness of the phenomenon. For a mountain cannot change its place. Now the shift in the aspect presented by the planet's disk from one night to the next is not sufficient to alter perceptibly the appearance shown by anything upon its edge on the two occasions. If then a peak stood out upon it one evening, the peak should again show salient when the region reached the same position upon the succeeding night. Then nothing that was seen where something had previously been visible proved the phenomenon, not that of a mountain peak, since what produced the projection was clearly not fixed in place and therefore not attached to the soil. Now the only other thing capable of catching the light before it reached the surface would be something suspended in the air, that is, a cloud. Deduction, therefore, from the rarity of the phenomenon alone showed that the projections must be clouds. Their behavior in detail entirely corroborates this deduction from their intermittence. Such was shown by the action of the projection of December 6, 1900, as set forth in a paper before the American Philosophical Society, and such again by that of the one May 26, 1903, as we shall now note. To begin with, we notice that the projection seen on May 26 was not found either in situ or in size on May 27, and had wholly vanished on May 28, though the seeing was substantially the same, if not better, on the 2 nights succeeding that of its original detection. Hence, in its own instance, this projection proved an alibi irreconcilable with the character of a mountain mass, but it did more. It not only was not on the second evening what it had been on the first, but the remains of it visible on the second occasion showed clearly it had moved in the meantime. Furthermore, it was disappointing as it went, for it was very much smaller after the lapse of 24 hours. The something that caused it was not only not attached to the soil, but was moving and dissipating as it moved. Only one class of bodies known to us can account for these metamorphoses, and that is cloud. But what kind of cloud are we to conceive it to be? Our ordinary vapor clouds are whitish, and this would be still more their color could they be looked at from above. The Martian cloud was not white, but tawny, of the tint exhibited by a cloud of dust, nor could this color have very well been lent by its sunrise position, for other places equally situated to be tinged by the hues of that time of day, Baltia to wit, showed distinctly white, so that we must suppose it to be, when it looked, a something of the soil, not beholden to atmospheric tinting for its hue. A vast dust cloud traveling slowly over the desert, settling slowly again to the ground. Precisely the same general course of drifting disappearance was taken by the projection of December 7th and 8th, 1900, and this too stood a unique apparition in the annals of its opposition. Clouds then, and not mountains, are the explanations of the projections on Mars, differing thus completely from the lunar ones. End of section 10 of Mars and its Canals by Percival Lowell, recorded by Mike Ferry 252.